Hi friends, I am James, automation engineer and PLC HMI programmer. Today I will show you one of my project. It is a gas detection system for one of the oil rig. It is H2S and LEL gas detection system. It means H2S is a toxic gas and LEL is methane, that is flammable gas in an oil rig. This system will detect the H2S and LEL gas and give alarms. It's a safety system. Let's see the HMI. This is the HMI and this main screen. This is one location in a rig. The HMI contains two portions. This portion is dedicated for fire system and this portion is dedicated for gas detection system. This is a area dedicated for drill floor, and we can see that small rectangular boxes. Each boxes are each sensors. Blue color box means LEL sensor, and orange color box indicates H2S sensor. These boxes is IO field will show the real-time gas value of the sensor. In this main overview page, we can see the location and all the sensors and the sensor real-time value: drill floor, main deck, mud pit, mud processing, shield shaker, engine room, first deck, second deck, third deck, rooftop, reed mounted sensors, and these are spares. And here also some spares are there. Total 54 sensors, and the AI card total AI channels are 64. Also 10 spares are there. Some of the spares are dedicated in drill floor, main deck. This top side, when we get an alarm, here we will get a pop-up message with location details and alarm details. Then we can go to the each page or each screen of this HMI. First, let's see drill floor. Just click the drill floor. It will go to the drill floor page. In the drill floor, I have these my sensors. Total 12 sensors are there. So 4 into 3, 12. And this blue color are LEL and this orange are H2S. This means this blue color are LEL sensors and orange color H2S sensors. Here we can see the sensor real-time value. Then its alarm settings, A1 and A2 alarm settings. A1 is 20, A2 is 40. All these parameters can be changed from HMI. It means that this is a standard HMI we can use for any of the rig. It means we can edit all the tests. Accordingly, when we get an alarm, the alarm test also will change. All the tests are connected to dynamic alarms. Here we can see sensor tags. I will explain one block of a sensor. Just go to the first block, LEL bell nipple. Just click. This is the configuration page of the particular sensor. Each sensor got its own configuration page. The configuration page contains LEL.
Attention on the rig, attention on the rig. Fire and gas alarm testing is completed. Fire and gas alarm testing is completed. Consider next alarm as a real alarm. Please consider next alarm as a real alarm.
In this configuration page, here we can select the sensor type. Either we need a H2S or LEL. So this sensor I can change to H2S sensor or LEL sensor. This block I can change, and that corresponding AI card just need to connect only H2S or LEL sensor. It means that this is a standard system we can use for any of the rig. and this AI card channel number 40. AI card channel number 40. So it's fourth AI card, the seventh channel 40. It's tag number. Here we can type the description of the sensor, like bell nipple. So this description here, two lines are there. This one, so 3 lines I can write. On each line I got around 16 characters, and I can select low alarm, high alarm settings. So whatever settings I want, I can give that settings. If I give 10% LL, then the alarm will comes on 10% only. And this is important. So that 40 milliamp set points, we are measuring the raw value from a sensor is 4 to 20 milliamps. But when sensor is faulty, it will give a raw value, not raw value, that milliamps. The milliamps will be less than 4 milliamps. So I'm giving a 3 milliamps as a set point. This is also I can change to 2 milliamps, or I can make it to 4 milliamps, whatever it's whatever we like. And this is on sensor calibration span. So when sensor got a span, so we can measure this one. So we can vary. Some sensor got 100% span. Some others sensor got a 50% like 50% LEL. So that we can select. It means that any type of the sensor can be added to the system, either 50% type sensor or 100% type sensor. And here we can see the gas value, the same gas value here. So the gas value, the same will be come on this screen as well. And this we can go. And this is the current milliamps, current reading. So at present there is no LEL gas, so that 4 milliamps. So when the LEL gas, the amount comes, so accordingly the milliamps increase, and that milliamps you can see. And if this milliamps go down, so then something fault, or so we can see it here. And the other options are accommodation HVAC and galley shutdown. It means it is measuring flammable gas. So when I fire flammable gas, means it's a possibility of a fire incident due to the flammable gas, like methane gas. When this gas is detected in the oil rig, immediately we can automatically shut down the HVAC of accommodation HVAC and galley equipments, in order to prevent the fire smokes entering into the accommodation area and reducing the oxygen level and causing the suffocation. We can select either we need to enable or disable. This sensor is located in drill floor area, so we need to shut down accommodation. So it's up to, if we need to select, we can select. So usually all the accommodation sensors will be selected for will be enabled for accommodation HVAC shutdown. And also we have A1 and A2 alarm. So whether we need to shut down at A1 level or A2 level, we have choice. And this is the drill floor shutdown. This is a drill floor sensor, so we enabled it. And at A1 level, so A1 20% level, it will automatically shut down drill floor HVAC. And here we have a sensor enable or disable option. If any maintenance purpose, we can disable the sensor. Now it is enabled. And inhibit mode is there. So when we calibrate the sensor, the milliamps will go less than 4 milliamps. Sensor output milliamps will go 4 milliamps, maybe sometimes, mostly it's 2 milliamps. So when 2 milliamps means it's a fault, but we can inhibit this sensor, so we don't get any fault alarm. And even though some sensors are giving some sensors may give a fault alarm after a long period of its operation, so those kind of sensor can be inhibited here. These areas can be only edited by the system provider password, and this, it means only administrator can edit, and all these gas values and the settings can be changed with the operator password. So two kinds of passwords are there. So if I need to edit something here, I have to put my password. My name is James. It's my password. James. Okay. See, now I already log in, and it's an administrator password, so I have access to edit everything. Either I can enable, disable, I can enable, disable, so even I can make changes. So this is LEL sensor, so I can make it to the H2S sensor. Now this become H2S sensor like this. See, now I just want to make it LEL normal, and this is 27 is the tag number here, so that I can, here you can see 27, I can just make it as a 271. See, the 271 will be tag number, so everything can be edited here. So I will just make it 27, and hi James. So I will put mine, I just see that. So I put hi JKV James, come here. So it's like we can edit, and when alarm comes, this text, whatever we edit the text, that will come as alarm description. Means all are dynamic alarms. Here I can change similarly LEL, H2S. So see that this is percentage LEL. So if I am going to select H2S sensor, this will be become H2S unit. So we can change the sensor span, calibration, and even I can disable sensors or enable sensors, whatever it is possible. So I'm just going to logging out this page. I'm just log out password. So similarly, I have other different locations: smart processing area, mud pump, engine room, main deck, real mount. So all this area, these are spare sensors. This also spare sensors. So people can connect some sensors in the future because all are configured. So they just need to connect. In brick floor we have two spare sensors, and also mud processing. We have mud processing area, two sensors are there. So like a main deck also, two sensors are there, one LEL issue, then other 4 sensors here. The total 10 sensors are spare. And I will explain the operation. So when any fault comes, this block will blink in yellow color, and we get a pop-up message here that in this particular location we got a fault, and we can reset it. We can acknowledge the alarm. When we reset it, it will not blink, but it will be steady and it will be in yellow color. Now the system is running, so we're testing everything over. The system is running, so I'm not just going to give any gas right away because it's already connected to all the sounders and we can this rig. It will give an alarm. I will explain all these things. When an alarm comes, it means any low alarm or high alarm, this green color will change to red color. It will change to red color, and red blinking will be there. When we acknowledge it, it will be steady. This is same for all the locations. You have mount all the locations, and similarly this block is also same. When system is healthy, everything are green. When faulty, the particular block will be in a yellow color, blinking with the sensor loop fault text. And when an alarm comes, this green will change to red and blinking. This is the basic operation of the system, and we can change all the tests. We can change, suppose tomorrow one sensor is connecting to any other location, such as, for example, well test area. Just need to add a well test area here. So no need to call any programmer, or no need to spend additional cost for a new project. This is for a long long period system, because once you installed it, you can use for a long time with the least service. Here we use Siemens S7500 comfort type HMI. I'll show my this is on a repeater HMI. I have 3 other HMIs are there in other 3 locations. I'll just go show that system health. This is my system health page. Will show all networks. I have a 7500 PLC with a power supply module, and here is ET 200MP and a 1 DI32 channel, 1 DO32 channel, and 7 numbers of I have AI cards. For the total I have 64 channels are there, and I have configured 64 AI analog sensors. Here I have 2 Moxa optical fiber Ethernet to optical fiber converter. Also this blue color line is optical fiber cable. This green color is Ethernet cable. It's a Profinet. 3 HMIs are in 3 locations. One is in my radio room in that PLC panel itself, and the other is offshore installation manager's office, and the last HMI is a controller cabin where I'm standing now. Also these are AI card informations. So when any fuse blow out, it will give a alarm here, or any fault in the AI card it will give. And one more thing I can show, this one. See, this is a diagnostic view of this PLC system. So everything are healthy. It's showing a green color. If suppose something is faulty, it will show red color, and we can double click and we can find the reason for the fault. So everything are healthy. So PLC, all the status we can see that. Suppose any fault or any wire break, it will show here wire break. So it's a complete diagnostics of the system. And here I have a current alarm page. There is no alarm right away. I just close it. And alarm history, I have so many alarms. I tested all these systems. A lot of alarms are there. And from system health, and here gas drill. So in the big case, they usually do some fire and gas testing. Testing of the beacons, or testing of the H2S or LEL beacons, or H2S drill or LEL drill. So these all things can be done here. So now I log out from my password. So I click here with the administrator password, then it will work. So we can activate, deactivate. Now all the gas drills, everything deactivate. When we want a gas drill, so just click it, it will switch on and it will give the gas drill. We have acknowledge alarm, we can silence alarm, we can reset alarm. We here this portion is dedicated for fire system. Also we'll incorporate some more features in this one. Also the fire system is a Modbus based system with Tyco Minerva T2000 panel. So that system also planning to prepare fully dynamic type HMI where anybody can change or all the details, and anybody can make any configuration. Any administrator can make any configuration with from the HMI. It means that when we add any new fire detector, or that we can be add from HMI itself. So that HMI, the page will contain that loop diagrams. From the loop diagram itself, we can select it's a call point or it's a detector, so whatever it is. So it's just a overview of the system. Hi, thanks for watching.